Hello, welcome to our print2mold webinar today. My name is Tom Krause. I'm the head of the 3D printing department, and this is my colleague Dhruval.
Hello, Tom. Hello, I would like to welcome you all. Myself, Dhruval Raval. I'm responsible I'm a development engineer of print2mold and specifically responsible for print2mold department. Hello.
Yeah, hello everyone. And yeah, if you have any questions, don't hesitate to write them in the chat. We will answer all questions afterwards. So for everyone who hasn't so much contact with igus so far, we are doing a really short introduction to igus. So igus is all about motion plastics. We are developing our own plastics which are free of lubrication and which are used in lots of different applications where wear and friction matters. And there are two big areas. There's the energy chain department where we're producing energy chains with the cables, and also complete ready chain systems where the cables are already mounted to the chains. And yeah, the second big product group is the dry tech department, where we are producing bearings and spherical bearings and linear guides out of our plastics, which are free of lubrication. And yeah, on top of that, in the last years, there were also several other products developed around the big topic motion plastics. And this can be bar stocks, 3D printing materials so that you can print your own special wear parts, rotary table plane bearings, ball bearings, 100% out of plastics, low-cost automation, linear axis, and lots of more products where wear and friction matters. And at all igus products, we want to fulfill always three promises. The first one is improve technology and reduce costs. If we cannot reach both, then we want to have at least one. And if you cannot reach one, we won't quote, because then we don't have an advantage for the customer. And the second promise is it can be calculated online. So there's a saying at igus, it's not an igus product if it cannot be calculated online. So you will find to every igus product an online lifetime calculation tool or online prices or some other way to get your lifetime or anything else calculated really quick. Yeah, and the third thing is fast delivery. We have more than 100,000 products, lots of them from stock, and different services to produce all kinds of special wear parts really quick for you, like 3D printing or print2mold, where we are speaking today about it.
Exactly.
So this is a really quick introduction of igus, and now Dhruval starts with some general topics about print2mold.
Exactly. Thank you, Tom, for introduction. So now I'll take over regarding the print2mold topic. Wear parts for different industry, like igus is mainly handling the wear and tear free part, lubrication free parts for different industry. We can produce, or the parts has been produced for igus for different industry, like mechanical, like aerospace industry, automotive industry, solar industry, cycle industry. Almost in every industry where the wear and tear parts are concerned, the igus product is being used, or print2mold parts is being used. So as you can see here, the different types of applications, like for the automotive seats, from headrest to armrest to this sliding actuator, the igus wear parts is being used. We have also the material with food applications, like FDA approved material, which can also possible with print2mold process. This automations industry, dental industry, any medicine equipment where the wear and tear is concerned, the igus parts is being used. So now, exactly.
Yeah. So, but what is print2mold, Dhruval?
Exactly, Tom. It's a nice question. So many of us like thinking when you firstly heard the print2mold, then it is just printing the mold and selling it off. No, it is not exactly like that. It is partially printing the mold but not selling the mold. The igus is not selling the mold. The mold will be kept on. We are producing the parts. Like the mainly print2mold is produce the wear part for the 3D printed tool, from the 3D printed tool for the injection molding technology. So this tool can be from plastic or from the metal. It depends on the customer requirement and the quantities, which is also suitable for rapid prototype, for functional parts or small scale productions.
And the main difference is, right, that we are 3D printing the mold, right?
Exactly, exactly. But we are 3D printed the mold, but from this mold, we are producing the part and we
Yeah.
deliver the part to the customers
Yeah.
as per the requirements. So
in which cases do you use print2mold, and in which cases you use other technologies?
exactly, I would like to make the light on it that parts where wear and tear and self-lubrication is the concern, then print2mold is considerable. Pre-series parts like from original material or material testing, the customer wants to test the parts, then definitely they can order the print2mold part, which is a little bit expensive for the conventional manufacturing method. Material required that cannot be printed with 3D printer, like high temperature, high conductivity, or high loads, then definitely by print2mold we can produce with all the material that we have in igus catalog, and we can use this all wear-free material for print2mold purpose. Fast delivery, that is the main points. Like for print2mold, you will get your parts delivered within 2 weeks,
Yeah.
which is unbelievable.
Yeah,
which is not
indeed.
compared with normal injection molding tool cases. And the tooling cost, definitely it is 60% lower than the normal injection molding tool. Exactly, yeah. We need a small and simple geometry without the undercut.
And with these all the materials we have available, I believe it's more than 50 materials.
Exactly. We have more than 50 materials for print2mold that we can produce. That we can produce the parts within from this material. But also we have some separate material which is in development phase or
Yeah.
like that. Then we can also you can find from igus catalog. So
Yeah, indeed. Then it's more than 100.
exactly,
Yeah.
more than 100 materials we have. So I would like to play a short video about the overview for the print2mold process. So please enjoy. So this is an online configurator that you can directly put your step file or STL file. And you can give the quantity, you can select your material as per your applications, and you will directly get the price. This is SLS method that we have in-house printer. We can also print for SLS, which is a laser sintering method. So this is SLA method, stereolithography. It's with liquid resins. And this is the metal, SLM method. So now this core and cavity will come together and the parts is being produced. So simple.
Indeed.
Exactly. So this is our print2mold department that you can enjoy lubrication-free bearings or lubrication-free wear parts.
So you can use any injection molding machine for this?
Definitely, we have different types of injection molding machine for big and for small, but it definitely depends on volume and geometry.
Yeah, but differences are the settings on the injection molding machine, of course, to regular molding.
Yeah. So
and yeah, what technology you use? You already explained it really quick. Maybe
exactly.
you can speak a bit more about
definitely. We have, as you've seen, that we have 3 different technologies like SLS, SLM, and SLA. This is the SLS, selective laser sintering method. Over there, I can show you some parts. My hand. This is the SLS parts. You can also show.
Yeah.
So over there you can find the surface roughness is a little bit higher than SLA and SLM because this part is produced with powder base, with the powder, and definitely it's a porous material. It's a little bit not stronger enough to like SLA or SLS, SLA or SLM. So this is a quick introduction for SLA. We have also SLS parts that's being produced here, as you can see on your screen. Different types of small igus button over there, the connecting rod over there, and you can also see the tools on your screen. So now we have SLA method that we already seen. This is with liquid resins, and with SLA, the surface you can feel, Tom. Yeah.
Yeah, it's quite nice. It's
quite
really
nice.
smooth.
Yeah, it's definitely really smooth and very glossy. That will directly reflect to the part. And with this tool, normally we are not promising too much quantity, but with small and simple quantity, we have produced more than 5,000 quantity with this tool.
Which is unbelievable. Out of a plastic tool.
Exactly.
Make plastic parts out of a plastic tool.
Yeah, there is some limitations that we'll cover later on because of the material. And yes, So this is the SLA. Now we can jump to the SLM method, which is a selective laser melting, which is a very versatile method and widely used or mostly offered to the customer because it's very versatile. As I see, there is very best precision. And yes, we can also show you some tools out of metal. These are metal tool.
So these, for example, here.
Exactly.
And yeah, how many pieces do I get out of such a tool?
Yeah, that is a nice question. For metal, we promise to minimum 10,000 pieces out of this metal mold. So which is quite good for the customer. So customer wants to, order for example, 100 to 100 pieces, then they will go for metal. Initial cost is a little bit higher than plastic tool, but it makes sense to make the metal tool because if the customer wants same parts further in future, then they just have to order the parts, not the tool. So definitely it is a very versatile method, and the customer can order the parts anytime if we have the tool already.
And we are guaranteeing the 10,000 pieces.
Yes.
But I think so far we didn't got anything broken so far, so we also getting more parts out of it.
Yes, yes. So now three technology comparison, like there is advantages and disadvantages always with the technology. With SLS and SLA, it is a little cheaper than metal, definitely because it's plastic. But there is limitations regarding the material. Because of SLS, we cannot produce the parts with high temperature material because it's a plastic. So low temperature material is only possible. Rough surface, distortion is possible. It's just suitable for low quantity only. So as compared to this both process, SLA and SLS, we have a winning process is SLM because the metal, best precision, high elongation at break, suitable for low and high quantity till 10,000 pieces, as I explained, and which is suitable for all ignited material. The second point I would like to highlight, it's tool electric heating is possible with metal. So if the material has a high shrinkage, then we can compensate the shrinkage with initial preheat the tool, which is not in case of plastic tool. So these three technology we have. Now the questions comes definitely in your mind about demolding, yeah, Tom?
Yeah, indeed. So what are we doing? We're having manual molding and automatic. When do I use which one?
Exactly. We have two types of molding process. Like till 30 quantity, we can propose the manual demolding, and up to the 10,000, like 30 to 10,000 pieces, we propose automatic demolding, which is the two cases. I'll play a short video for the participant to get an overview about the automatic demolding. So this is the automatic demolding, which is a normal injection molding process, which can directly, situated with ejector pins and ejector plates over there, and the material will be molten with this plastic, with this metal screw, and it will come to the enter the cavity. The molten plastic will enter to cool down, and it will ejected with ejector pins. So this is the video of automatic demolding. Now we have the video of manual demolding. So it will explain what is manual demolding. So over here, the advantage that definitely we'll cover later. And next slide, maybe we can produce the parts with undercut. So this is the core that we'll place on the undercut area, and then the technician has to put the tool manually. Then core and cavity will come together, holding the pressure, enter the plastic, as you can see, the filling the cavity.
Looks quite nice.
Because it's a transparent SLA tool, so we can also see.
Interesting for checking how the mold is filled and everything.
So it's cooled down, and the part will come out manually. So this process is a little bit complex and time consuming. That's why we're not offering more than 30 quantities.
So, what's the advantage then if it's such a manual process? I believe we speak later about it.
Exactly, we'll cover this topic later. We jump to the next slide. What is possible in automatic demolding? As you see, as I said and as I explained, we have the tool only open and close. At the moment, we doesn't have We don't have the tool with slider or something like that. So we only propose the simple geometry, undercut free, draft angle is possible because it will make the demolding very smooth. And maximum size up to 45 cubic centimeter, 100 into 90 millimeter. Yes, you can see different types of tool, different types of parts that we have that been produced with print2mold, flange bearings, simple spherical caps, bush, and the tool itself. It's over there. So with manual demolding, it's a little bit advantage in manual demolding, although it is complex, but we can do parts like that. Yes, it's a 2K parts, which is 2K material that has been produced with print2mold. So as you can see here, this part first we printed with SLS printer like that, and then just this blue material is the overmolded material. So these parts will go into the cavity like here, and it will overmolded with this blue material. So it's with two material, 2K parts is also possible with manual demolding, which is not in case of automatic. Same things, we have one more example here, that is SLS part. And here we need the conductive material, yes.
Yeah, so this is also a multi-material part.
Yes.
Where we printed the base part and we are injection molding a conductive material inside of this part to reach special properties here. And this is another example for doing development of special parts with much less tooling costs than would have been with a regular molding, because 2K parts doing in a molding is usually a really expensive.
So in between you can also fit these parts to to pass the current. Like it's a conductor material. So this is the advantage, a little bit advantage manual demolding over automatic. But as I explained, like automotive is very versatile, and we can propose or we can offer to customer only the automatic at moment, because as I said, it is a very versatile method, I would say.
Yeah.
So now I'll jump to the tolerances. Definitely the questions comes in your mind about the tolerances, because it's a plastic and 3D printed tool. But overall, plastic tools like SLS and SLA, we have a tolerance limit up to plus minus 0.2 to 0.4.
Yeah.
And for metal, we have a tolerance limit average plus minus 0.1 to 0.2.
Yeah.
But that definitely depends on the shrinkage of the material, selection of the material. We have 3 different types of category: high shrinkage material, medium shrinkage material, low shrinkage material. So if the customer is choosing, for example, the material J, which is high shrinkage material, then definitely we would advise them to choose a P200 or something like that, which has a low shrinkage, but it's the same applications. So that could be filtered, or that could be advised or assessed by us manually. If you send your request, then definitely we can advise you regarding the material process and material choosing. You can see here in your hand this tool and parts.
Yeah, and I think this is a good example.
Exactly.
We have, of course, a certain precision of the mold, which is in this case 0.1.
Yeah.
And we have the same precision in the part. And there are lots of applications where this is really fitting, as here. We made these gears here, and it worked quite well in the customer application. And of course, there are also applications where you need to have a much higher precision.
Yes.
But most of the applications or most of the customers we have, they're quite happy with getting these injection molding parts that quick with the reduced tooling costs.
So this is our new technology that recently been introduced. These are small inserts of metal, which is being printed with metal, but it is printed with different technologies. So here we'll get the fine resolution. Or in the SLM process, the metal normal SLM process, the surface roughness is around 4 to 5 μm, but here we'll get the surface roughness around 1 μm, which is quite good actually. And the tool cost definitely will be higher than the normal tool, but if the surface roughness is a case for the customer, then definitely they can go for this new technology tool. Here we have some limitations regarding the part size, because we cannot print a big tool at the moment. But definitely later on we can also introduce with a big tool with this fine resolution. It is really good surface.
Yeah, it's really indeed. It's like like polished. It feels like a polished tool here.
Exactly,
really. It's really
exactly.
quite nice.
Yeah. So now I would like to, share the screen because of the suitability on print-to-mold process. As you can see, how the request will be filtered. Your request will be filtered by us. If the part size is, more than 100 or 190 millimeter, then definitely the case will be, the part will be checked and modified as per requirement. If this is not the case, then you can go for 3D printing, bar stock, or normal injection molding process. If the part size is in between 100 into 90, then definitely you can go further. The volume size will check more than 45, then definitely part will be checked again. But in this case, if the customer have 50 or 60, then we advise them to remove the material, or we can do by ourselves in designing or in design CAD designer.
Yeah.
We can reduce the part. We can also provide the ripping that the customer parts will be suitable for print-to-mold method. Undercut free design possible. Undercut design possible till 30 pieces because manual demolding. Quantities are more than 30, definitely suitable for print to mold. Easy geometry, directly suitable for print to mold. If the complex geometry is there, then definitely the print to mold is possible, but the assessment is required. So if we can, manually filter the request and we can see the parts if it's feasible with print to mold or not. So this is the filter that will filter manually, but the customer has not this type of complexity to filter because we have the online configurator tool.
Yeah, quite nice. So you don't need to think about the details. Just go online. Dhruva is showing to you now. And just submit your request to us, check prices really quick, and then we take care for everything. If you have also, because it can be complicated for customers, as already mentioned, we have more than 50 materials.
Yes.
And there are also filters in the tool where you can filter by application temperatures, by FDA conformity, and lots of other filters, so it's also for everyone who doesn't know the igus materials. It's really easy to check what's my suited material and then check which method to choose and what are the prices.
You can make the filter according to applications. There is 4 or 5 filters available over there. So user stories we have. Tom?
Yeah, this is an interesting user story here. This is an AI-controlled waste disposal system where it is separating the different types of waste. And this customer needs only like 100 or 200 pieces here, which is suited for print-to-mold because the regular injection molding the tool would be far too expensive here. And this customer used 3D printed parts before. And we could reduce the costs here by 50% by switching to print-to-mold. And this is already the case at the first order. The customer were already able to reduce costs, and at any more orders, he already paid the tool, and the cost advantage is even higher. Yeah,
it's more than 50% cost advantage. And within 2 weeks, we delivered the parts. And the customer is using this product. It's an AI-controlled robot. I can play the video for you. Yes, it is an AI-controlled waste management system, which is really good.
Quite nice.
Yeah. So it is continuously running, yeah?
Indeed, yeah.
Yeah.
So it's also showing very good why to choose igus, because we are developing these plastics where the solid lubricants are inside, where you have the lifetime which can be calculated, and where you have a lifetime which is much higher than with a regular plastic.
Exactly.
And this is really the kind of applications where you would choose igus, where wear and friction matters. Really.
Exactly. So another user story that is being used for household appliances like a washing machine or like a dishwasher. This is a bearing cage that we produce with print-to-mold, and this is 50 times lower tool cost as compared to conventional tooling, which is unbelievable. And we deliver, we printed this tool in 3 days. We delivered the parts within 1 week. So so igus is suitable for every industry, as I explained earlier. And this type of material, which is not possible, or which is which cost higher than the normal print mold, then I would say it will cost higher in injection molding process. The print to mold is considerable.
Yeah.
So this type of user stories we have. And not, this is last slide, but I think not, yeah.
So yeah, so this is about the print2mold, and as this last slide, we just want to add to you that we at igus, of course, not only doing print2mold, we are also doing regular injection molding, and especially with for bearing shaped parts, we have a special service which is the fast line service, where we can do bearings and similar parts of bearings like clip bearings in a special fast line service, where we can do these parts within 7 to 10 days. So if you have special bearings, we would check for you what's rather suited, the fast line or print2mold.
Yes.
And because at print2mold we usually do more complex parts than simple bearings.
So I just want to add some points because of the in the fast line, you will get the original injection molding parts like within 7 to 10 days. The tool cost is a little bit higher than print2mold because it's a mill tool. But if it is the case like the customer or you want to feel the original parts, then definitely the fast line is also one of the options for igus.
Yeah.